tangents. We need to find the length of the tangent drawn from the point 1, 3 to the circle defined by the equation 2x squared plus 2y squared equals 9. First, let's rewrite the equation of the circle in its standard form, which is x squared plus y squared equals r squared. To do this, we divide the entire equation by 2. This simplifies to x squared plus y squared equals 9 halves. From this standard form, we can identify the center and the radius of the circle. The center is at the origin 0, 0. The radius squared is 9 halves. Therefore, the radius r is the square root of 9 halves, which is 3 divided by the square root of 2. Now, let's visualize the situation. We have a coordinate system. Here's the circle centered at the origin 0, 0, 0 with radius r. And here's the external point P with coordinates 1, 3. We draw a tangent line from point P to the circle, touching the circle at point T. Let's draw the radius OT from the center to the point of tangency. And let's draw the line segment OP connecting the center to the external point P. A key property here is that the radius to the point of tangency OT is perpendicular to the tangent line PT. This means that triangle OTP is a right-angled triangle with the right angle at T. The hypotenuse of this triangle is the segment OP, the distance from the center to the external point. The legs are the radius OT and the tangent segment PT. We can use the Pythagorean theorem, which states that the square of the hypotenuse is equal to the sum of the squares of the other two sides. In our triangle, this means OP squared equals OT squared plus PT squared. Let's calculate the lengths needed. We already found the radius OT, which is our equals 3 over the square root of 2. Its square, OT squared, is 9 halves. Next, we calculate the distance OP from the center, 0, 0, 0, to the point P, 1, 3, using the distance formula. OP equals the square root of 1 minus 0, squared plus 3 minus 0, squared, which is the square root of 1 squared plus 3 squared, or the square root of 1 plus 9, which is the square root of 10. So, ob squared is 10. Now we substitute these values back into the Pythagorean theorem. We have 10 equals 9 halves plus PT squared. We want to find PT, the length of the tangent. Rearranging the equation, we get PT squared equals 10 minus 9 halves. To subtract, we find a common denominator. 10 is 20 halves. So PT squared equals 20 halves minus 9 halves, which is 11 halves. Finally, we take the square root of both sides to find the length PT. PT equals the square root of 11 halves. We can also rationalize the denominator by multiplying the numerator and denominator inside the square root by 2. This gives the square root of 22 over 4, which simplifies to the square root of 22 divided by 2. So, the length of the tangent drawn from the point 1, 3 to the circle 2x squared plus 2y squared equals 9 is the square root of 11 halves, or equivalently, the square root of 22 divided by 2.